Hello, welcome back. Episode 12, still on static mechanics. We are picking the equilibrium on inclined plane. So in this question, we have a particle of mass 10 kg is placed on a rough plane inclined at an angle of 30 degrees to the horizontal. So we are looking for what force acting parallel to the plane is required. One, to hold the body at rest. Two, just to cause the particle to move upward. In these questions, we need to make a sketch of the diagram that is having the object inclined. So if the particle is resting on this surface, then the angle of inclination is given as 30 degree. The center of the object will have a force pulling it down called the weight, and the weight is also equals to the mass times what? Gravity. Then we have a force perpendicular to the surface called the normal reaction, which has a downward force. This will be a straight line. I'm not using ruler, which is having cos theta. So for this body to be at where it is, then we should have a force which is gravitational pull pulling it down, and a frictional force holding it. So the two forces are doing tug of war with it. So if nobody's strength is bigger, the body remains at rest. So we can see that this could be our gravitational pull pulling the object down, which is what? Mg sine theta. I'll write it in this way. And there is a force which is also friction pulling it up. Then we are looking for that force that will be applied to the body so that the body will still be at what? At rest. You know, there are times when you put an object on top of a table sliding up, then the body begin to move down on its own without any force applied. So at that point, it means that the gravitational pull pulling the object is bigger than the friction between the object and the table, right? But when you put it on it and it is not moving, it means that this your mg sine theta is the same as the friction holding it. So they are doing tug of war, right? Now, so at that point that is not moving, then we are also looking for that force that will make it stop. Or when it is sliding, we want to see a force that will be applied either by a push or by a pull that will hold the body still standing in there. So that force is what we are looking for. And that force will be a balance between those forces pulling it up and the forces pulling it down. So if the two are equal, the body will be at rest. So for the Roman number 1, we can say that forces, if you can, parallel to the plane. Those forces is going to be P is going or pushing it up against the gravitational pull. Friction is also doing same. That will be equals to mg sine what? Theta. Let's just say this is our first equation in here. We are looking for that force P, right? We know mg sine theta as 30. Here is also 30 degree. Then the only thing we need is the frictional force, which we know is proportional to the normal reaction. So I can say that your frictional force is directly proportional to the normal reaction, where the constant of proportionality is the coefficient of what? Friction, given as what? 0.4. So in this case, I need to know what the R is. The R is also forces perpendicular to the surface. So we can say that forces perpendicular to the plane is going to be, these are perpendicular forces which are right angled to the surface. So the upward force, which is the normal reaction, should be equals to the downward force mg cos what? Theta. So the upward force equals to the downward force in this case. So we can find the normal reaction easily from here. So can I say this is my equation 2 since I'll be using it again? Let's see. This will be mass 10, gravity 10, cos of the angle 30. Let's see 100 cos 30, what it will give us. So that will be giving us, so we leave it in decimal or in set form. Okay, in set form we'll keep all the values. So 50, the root of what? 3, which is going to be a Newton, it's a force. Then from the other side, this implies that your force will be equals to, this is known as what? 0.4 multiplying the 50 root what? 3. I think we can do that in decimal. Let's do that in decimal. So times 0.4. So that will I be using it again? Okay, I'll be using it again here. So let's maintain that as okay, let's go. 34.64. This is Newton, it's a force. So this is going to be 34. That is the frictional force, which will be adding to this equals to this, or this minus that will give us the force we are looking for. So let's see how that will be spun out. Okay, so we have this. We can pick from equation 1, where I think I can make my P, the subject, equals to mg, which is the mass 10, gravity 10, sine of 30 minus the very answer we have here as what? 34.64. So I think this will be giving us 50 something, I guess. So 100 sine 30, that will be 50. So 50 minus 34.64, and that will give us 15.36 Newton. So the force that is required parallel to the surface or the plane that will hold the body at rest is going to be 15.36 Newton, or just 15 Newton. All right. Then for the second part, we are looking for the force that will push this to move upward. Remember, if the force is going to push this upward, let's see, can I make a different diagram? This is the weight coming down as what? Mg 30. We have this to be mg cos 30. The normal will also be here as this. Now remember, as the force is applied, let me increase this. So this is the normal. So as the force is applied to the object, you know, when the force is applied, it means that it's pushing this upward. For it to move up, the friction will no more move against it, or will no more move alongside with it, just like it is in this place. The frictional force in there holding it, so we are not pushing against it. We are just trying to hold the body. A little force in there, which is having some, let's say, the sum of that force and that of the one moving up should be equals to the force pulling it down. But here we are pushing it up, so it is moving in the upward direction, and always there is a friction that is causing it not to move. The frictional force prevents the movement of the object, so it means the frictional force will now be moving against it. If you have a ruler, you draw a line nicely. So this is going to be the frictional force, and already there is a gravitational pull also happening here, mg sine theta happening. So you can see that in this case, if I am taking forces parallel forces parallel to the plane, I need to have a balance of this force. Upward movement, P should be equals to the downward movement force plus what? The mg is that sine theta. Let's look at the two diagrams carefully. This one, the body is at rest, is at equilibrium, no movement. Here we are breaking the equilibrium. So if we are breaking the equilibrium, it means that the force we are applying over seed any other forces holding the body. So as we are moving up, this force, which is friction, there is also a gravitational pull. You know, when you throw object in the sky, the object does not stay. It tries to come down. The fact that the object has weight on its own, there is also a gravitational pull pulling the object down, right? So that pull is taking place as well, mg sine theta. Then since there's a surface, rough surface, there is a friction working against your push also. So this means that there is a double movement downward and one movement up, and that gives us what we are seeing in there. I think we know what the force is here, so I'll only add 34.64 plus 10 times g, right? 10 sine 30 degrees. And if I do that, I should be having 100 and this 50. So I'll have 34.64 plus 50. That should be giving me 84, right? Point what? 64 Newton. So the next force that we are looking for, that is causing, or that will cause the object to move upward, is going to be 84.64, or better still 85 for Newton. Let's look at the difference in the two diagrams. If you have any other way by which we can calculate the two questions, I would say two parts of the questions, feel free to share that in the comment section as we keep learning together. Like, comment, and subscribe.